So very good afternoon, everyone. So here we are going to continue the electromagnetic field theory, and the chapter is on your wave propagation. So in this wave propagation, we will see the first content or the topic in the wave propagation is nothing but the wave propagation in the parallel waveguides. So before going to start this session, first of all, we should aware from the basic concept which is related to the waveguides, because already we have studied in the uniform plane wave what is mean by the wave, how my wave can be propagate, how that wave can be travel in the free space. That already we have studied, but now this is the time to study about the waveguides. What is the use of that waveguides? Why we are interested to study about the waveguides, that is important, okay, and how that waveguide will play the role in the wave propagation, that is important. So what is mentioned here, the waveguides is one of the structure or the what we can say, the formation that guides the wave, such as the electromagnetic waves, or you can say the sound waves, all these things to minimize the losses of the energy, or you can say for the restricting the transmission of the energy to the one direction only, okay. So in short, you can say there are a difficulty while my wave is propagating or traveling in the transmission line. So there is a one additional alternate by which I can propagate my wave, I can travel my wave, I can pass my wave from the one place to the other place with the help of that waveguide, in short, okay, getting. So because this is the one way through the transmission line, my signal is passing from the one place to the another place. So that is one of the medium is nothing but the wired is a transmission line. There is a wireless also, but here there is a additional alternate the way by which you can our wave can be propagate, our wave can be traveled from the one place to the another place is through the wave guides. Okay, by if you are going to use that wave guides, definitely the you can say you can minimize the losses which is coming over the while you are going to use the transmission lines, okay, because we know very well in the transmission line the energy or you can say the wave which is traveling is from the one place to the another place in the one direction, means the straight line. Similar to that only, the wave guides are the formation, or we can say the availability are in the metal tubes. The waveguides are available in the metal tubes, and the function which is used in the metal tube is nothing but they are conducting and they are carrying the electromagnetic waves. So in short, they are practical only for the signals. If we are having a high range of extremely high range of the frequencies, so if we want to travel that signals, okay, that waves, that signals which is having the extremely high range of the frequency, and we know very well if the extremely high frequency is there, definitely we should think about the wavelength also. At that particular moment you can go for the, you can approach for the wave guides. The thing is that how we can pass our the waves, how we can travel that signals, what are the possibility by which the wave can be propagates in the waveguides. The wave can be propagates in the waveguide. There are various or types of the waveguides through which our wave can be propagates, our wave can be travel, our signal can be passed with the help of the waveguides by using by referring with the help of the various the waveguides. What are that waveguides? There are various kinds of waveguides are available. Number one, rectangular form of the waveguides. Number two, circular waveguides. Number three, elliptical waveguides. Number four, the single rigid waveguides, and next is the double rigid waveguides. So all these waveguides are useful depending upon the application and depending upon the length on other parameter. You should think over it which is suitable for traveling propagating that wave, okay. So the availabilities are many, that is the rectangular, circular, elliptical, single, and the double rigids. But the thing is that how you can pass, how you can keep in your mind by which you can think over it which is better for so and so application. You may use the rectangular, you may use the circular, you may use the elliptical, you may use the single and the double rigids. So these are the availability, you can say, these are the types, you can say, the waveguides. while you are going to learn about the waveguides, we should know the energy which is transmitting in the form of your the electromagnetic waves in the transmission line. It's transmitting from the one place to the another place in the form of your the voltage and the current, that we should aware how much amount of the energy that is transmitting. Okay, because already we have studied in the uniform plane, we have studied in your the transmission line, the energy is transmitting from the one place to the another place. We are interested at the end also, we need to calculate. W is also the energy work to calculate while the wave will be traveling from the one place to the another place. Similarly, how much amount of energy will be required in the waveguides while transmitting from the one place to the another place in the form of your the electromagnetic waves. Okay, similarly, the conduction of energy takes place is not through the walls whose function is only to confirm this energy, but through the dielectric field in the waveguides, which is the usually the air. We know very well, if I'm going to pass my the wave, I'm going to pass my the signals, so definitely the energy will be conduct, or there will be the conduction of your the energy. Okay, so that may be the wire, that may be the wireless, that may be the transmission line, that may be the sound waves, any. But the thing is that whether it's a passing in the free space, so which things are the medium. So here the one of the medium you can say that is nothing but the dielectric. What is the use, why we are preferring, what are the advantages of your the waveguides instead of preferring the transmission line? In short, if my wave is propagating, my wave is traveling, my signal is passing, so instead of preferring the transmission line, I can prefer the waveguide. Just now we have discussed on that. Instead of preferring the transmission line, we are using the medium, or you can say we are using for propagating, for transmitting, for passing that signals as through the waveguides. Okay, so what is the benefit of that? Why we are studying that thing? Why we are, which things are beneficial? What are the advantages of that waveguide, so that we are preferring instead of the transmission line these waveguides? So the thing is that mentioned here, in the transmission line, the high frequency signals cannot be transmitted. Okay, what I said in the previous slide, extremely high frequency ranges are preferred in the waveguide. Similar to that only, what we mean to say here, in the transmission line, the high frequency signals cannot be transmitted because of the many reasons. So few are listed here. Which are the reason by which we can't transmit over the high range of the signals or the high ranges of the frequency signals? Just because of the large mutual inductance. Just because of the large mutual inductance. See here, already we have studied in the transmission line the series and the parallel combination in the transmission line. In the series, we have observed the resistor was in series with your the inductor, whereas the capacitor was in series with your the conductance, and this R and the L were in series, whereas the C and the G were in the parallel. That is nothing but the shunt connection, and here was the series. So in short, you can say the inductance plays the major role in the transmission line, and whenever we are connecting the inductances, number of inductances, so definitely there will be the coils. If number of coils are present in the inductances, definitely there will be the mutual inductance. If the side by side coils are connected in the transmission line, definitely there will be the mutual inductance takes place. Okay, mutually induced EMF will be formed. Already we have studied in the network analysis, that is a mutual inductance. Okay, self mutual inductance and dynamic mutual inductance, that already we have studied in the network analysis. If two coils are present near to each other, then definitely while what we can say, from the primary to the secondary, the energy can be transferred. Okay, how the energy can takes place, that we can observe how the mutually induced EMF can be formed from the one place to the another place, or from the primary to the secondary, from the one coil to the another coil. Okay, that all we have L1, L2, that already we have studied in the network analysis. So similar to that only, while the number of inductors are connected, coils will be present, and they will be interact to each other. Besides that, coils means one coil will be mutually connected to the other coil. That's why there will be the large possibility of a large mutual inductance will be created, which is not beneficial, or you can say gives a harmful in the transmission line. Second is the length is a very large. Obviously, we have studied the lambda is changing every time. We have studied from the source to the terminating impedance. There is a huge line, wide range of the distance is there. That is every time the Z is equals to L and the L will be equals to X, means there will be the variation in the length. So that length is larger. This is the what we can say, these are the drawbacks in the transmission line. Even the multiplexing signals is not possible in the transmission lines. Okay, multiplexing signals, number of signals you can't pass even while you are going to consider the transmission lines, because on that particular transmission line, particular frequency is useful for propagating that waves, okay, for getting the benefit of your the communication or the entertainment. Likewise, these are the examples. Okay, so in short, for the multi signals, for the multi application, it's not possible to transmit. Next is nothing but the flashover is less in case of the waveguide. What this is the disadvantage, you can say, in the waveguide, whereas the lacunas which we have found and the advantages of a waveguide is there will not be any kind of the mutual inductances, the distance will be the shorter, the multiplexing signals can be passed in the waveguides. Okay, even the minimum loss of the power, because already we have studied with the help of the pointing theorem, we were interested to calculate the average power as well as the pointing vectors, and we were interested with the help of that pointing theorem, so we have calculated the average power loss. Okay, so that power losses are less if you compare with the transmission line. Next is nothing but the power handling capabilities 10 times larger than the coaxial cable. So obviously, if you are thinking about the other medium, then in that case also, the power handling capabilities or the power is larger power or the power energy, consumption of energy in the, you can say, the waveguide instead of the other coaxial cables, or you can say the other optical fiber, you can say the transmission line and all. So in short, you can say this will the beneficial of your the waveguide or the advantages of your the waveguides over the other things. Secondly is your the mechanical simplicity. The structure which we are observing is also the rigid type, and that you can say the simple form, instead of if you are going to study about the transmission line, which is somewhat complex just because of the all the components which are connected, just like your the series and the shunt connections. Okay, next is the higher maximum operating frequency which is available while you are going to study the waveguide, that is nothing but 3 gigahertz to the 100 gigahertz. So next is nothing but we know very well, just now we have seen what are the types of the waveguides. The most widely applicable or useful the waveguides are nothing but your the rectangular waveguide as well as your the what we can say the circular waveguides. Okay, rectangular as well as the circular waveguides. Now come towards the next, that is nothing but next is nothing but you are the what. So next so you can observe in this case, that is nothing but the if we are having the magnetic flux lines which is appearing as a continuous loop, and we know very well the electric fluxes lines will be appear from the beginning to the ending, or you can say from the source to the destination. So here the mode of the what we can say wave propagation is mentioned. We will see in the next slides what is that TE, what is that TM. But in short, you can say if this is the shape or the structure of your the waveguide, how the electric and the magnetic formation or the field will be occur, how the formation of the field in the electric as well as the magnetic field is made, shown here. Okay, so here how my wave will be propagate in the electric field, how my wave will be propagate in the magnetic field, how they will travel, whether it's a rectangular form, whether it's a circular form. See here the shape you can identify easily, these are the rectangular form and these are the circular manners. So likewise the wave will be travel, the signal will be passes to the in the waveguides. So here, while you are going to study how my wave can be travel and propagates, so that waveguide modes, they are mentioning the modes. So what are that modes by which you can think over it, in which form, in which method, in which mode I can transmit my waves, that is important. So in the electromagnetic waves can be, we know very well the electromagnetic waves can be travel along the waveguides using the number of different modes, okay, by using the different number of modes. What are that modes? We will see here. The different waveguides modes have a different properties, and there is necessary to ensure that correct mode for any waveguide is excited and they are suppressed as far as they are. So in short, you can say while the wave will be propagate, okay, in the waveguides there will be the various kinds of method modes by which the wave can be traveled, and each and every mode have their different properties. By looking in the by keeping in your mind, as per your the application, you can pass that your the views, okay, in that particular modes. What are that particular modes? We will see here. So even in the electromagnetic and the propagates that waveguides, we know very well, but how that modes are possible by which you can pass your the signals of the views. See here. So one of the mode is nothing but, there are various modes. Number one is nothing but the TE modes. Number two is nothing but the TM modes. Number three is nothing but TEM modes. TE, TM, TEM. So what is the TE? That is nothing but transfers electric waves. Transfers electric waves. The wave guided mode is dependent upon the transfers electric waves. Many times it's also known as the H waves. Okay. The characterized by the electric vectors. We know very well the electric field is denoted by E and the magnetic field is denoted by the H, and they are perpendicular to each other the direction. So in short, you can say whenever we are talking about the TE mode, it means that we are interested to talk about the electric field. Okay, to talk about the electric field. And while we are talk about the electric field, definitely if we are study about the characteristics, then there that will be the in the transverse electric waves. Okay, while you are going to study, so you should aware from the properties, you should aware from the functions of that TE modes. And okay, we were interested only in the transverse electric, okay, while we are studying. Similar to that, second mode of your the wave propagation or the wave guide is nothing but the TM modes. What is that TM? Transfers magnetic waves. So see here, T stands for the transfers, M stands for the magnetic waves. If E is the electric waves mode, okay. So this TM is also known as where the E, that is nothing but the electric waves, are characterized by the fact of magnetic vectors, that is nothing but H, is always perpendicular to the direction of propagation. So in short, whatever the thing is coming, they are perpendicular to that line. Okay, which line? The direction of your the propagation of your the waves. Third is nothing but the TEM modes. That is a transfer combination of electric as well as the magnetic waves. That is important. Okay. So in this transfer, electromagnetic waves cannot be propagated within the waveguide, but it is included for the completeness. It means that by the combination of the TE, by the combination of your the TM, both can be included, combined or completed in the TEM, because TEM is nothing but the combination of TE plus TM. So if you are going to add the features, whatever we have calculated, the features, whatever calculated mathematical expression, anything which is came under the TE, that we should concentrate while you are going to combine. Secondly, the magnetic field, that is transfer magnetic, both can be added in the TEM mode. Okay. In this mode, commonly used within the coaxial cable, or you can say the wired feeders. So this both the electric as well as the magnetic field are perpendicular to the direction of propagation. So electric field denoted by the E vector, magnetic field denoted by the H vector. We remember, and both can be perpendicular in the TEM, because in the TE they are definitely perpendicular, but for the opposite direction of propagation. In the TM related to the E waves. In the TE related to the what we can say the M waves, vice versa. But if you're talking about the TEM, both will be present and both are perpendicular to the each other. So now we will start for study about the first type, that is nothing but the rectangular waveguide. So the representation, the structure, the image of your the rectangular waveguide will be this one. So here you can observe these are the waveguides and this is the hollow type. So the frequency high, extremely high range of the frequency will be coming from this side, okay, and they will be get back. Here will be the metallic horn. So many times you have heard about the shape and the horn. It's a similar to the horn shape. Okay. So see here, few waveguides components are placed here. How the rectangular waveguides are there. How the waveguide to the coaxial adapter is mentioned. How the waveguide can be bended. How the formation of the E can be observed. That is mentioned here. So these are the what is the component, okay, by which the extremely high range of the frequency can be passed in the mechanical structure of this waveguides, okay, metal or mechanical structure of your the waveguides, by which the extremely high frequency ranges can be passed from the one place to the other place. So see here how the rectangular shape can be looked, how the coaxial adapter can be looked, how the waveguide bended form can be looked, and how the E type. Because we have studied in the symmetrical and asymmetrical T and the pies of the look. By looking that, we can identify this is the T and the pi. Similar to that, only by looking this E, we can identify this is the ET. Similarly, many more waveguides are available. This is the one of the shape. So now come to the points. Finally, what is the necessity, what is the purpose, or what is the use of your the waveguides? What is the necessity, what is the purpose, and what is the use of your the waveguides? So each here lists are mentioned listed here. Number one is nothing but to reduce the attenuation losses. To reduce the attenuation losses, that is nothing but the alpha. And we know very well while you are going to use this waveguide, which is beneficial for the attenuation losses or reducing the attenuation losses, that is nothing but the alpha. So how it is possible? That is, it is possible by increasing the high frequency. It is possible by increasing the power. So how we can we can reduce the attenuation by increasing the frequencies ranges, by increasing the power ranges. Okay. So next is nothing but such type of waveguides can be operate only above the certain frequency. Just now we have explained that is extremely high range of the frequencies preferred in the waveguides. These waveguides are also acts as the high pass filter. Why it is so? Because the high ranges of the frequencies required that need to be passed. So that's why the high ranges of the frequency that matters, and they acts as a high pass filter. See here the rectangular waveguides, how they can be look in the 3D form, that is mentioned here. The formation already we have studied in the vector analysis, how the X, Y, and the Z. See here, upper position is the nothing but the Y, this one is in the Z direction, and this one is in the X direction. See here, vertical is the Y, slanting is the what we can say horizontal is the X, slanting is the Z direction. So in this way, all these things can be mentioned here. That is nothing but the Y direction, X direction, and the Z direction, how they are placed in the what we can say in the rectangular shape, that is shown here. So here, while you are going to study the rectangular waveguides, so need to be find the field components of in the electromagnetic wave instead of the waveguide. So what are that field components? We know very well the points are X, Y, Z, but X, Y, Z in the electric, X, Y, Z in the magnetic, we should identify easily. So what we have done, instead of taking the E of X, Y, and the Z, see here the E of Z, E of X, and the E of Y. Similarly, H of Z, H of X, H of Y. So all these are showing the combination of your the electric as well as the magnetic field. Okay, electric as well as the magnetic fields are shown here. How we are taking this E and H? Whenever we are talking about the TEM, both the combination of your the electric as well as the magnetic field. If single is there, TE is there, you need to write the expression for the E. If TM is there, you need to write the expression for the M. And if the combination is there, that is nothing but the TEM. So you need to think over about the electric as well as the magnetic. So see here, in the rectangular waveguide, how the fields are inside. So using the phasor diagram, you can say, using keeping in the mind how the lossless dielectric material or the perfect conductors are available, how we can write the expression of here the electric as well as the magnetic field is mentioned here. See here, the del is nothing but the gradient. Okay, del square of E plus K square of E is equals to 0. So here the electric field is there, that's why E is mentioned here. Okay, this is the constant term K and this is the gradient. Already we have simplified. Okay, so what is the value of your the what is the K? K is equals to, how we can find easily what is my K? K is equals to omega square into mu C, omega square into mu C. So here the expression in the what we can say, the gradient is mentioned along with your the constant parameter. This expression related to the electric field, this expression is related to the magnetic field, and here mention how we can substitute the value of the K. That K is equals to root of, okay, that K you can write a root of omega mu epsilon, which are the constant parameters. Similarly, the mode of operation, what we can say, the mode of propagation. In short, the mode of propagations already we have studied. There are various modes of propagation: TE, TM, TEM. Okay, so here now again pay the attention how we can write the expression or the equation we can write here. So in the TEM, the combination of your the electric as well as the magnetic field. So obviously, if you are in the Y and the X plane, so definitely my Z plane will be the 0, or that is not propagate, cannot be propagate, that plane will not be propagate, because I am in the Y, I am in the Z X direction. My E and the H are in X and the Y direction, then definitely the other last parameter, that is the Z, will be treated as a 0, which can be propagate. Similarly, if TE in the EZ direction and TEM is in the HZ direction, both are in the Z direction, definitely the both are in Z direction. Definitely, while you are going to study about the TEM, so what will be my case? What will be my case? The other parameter will be they are in the other planes, just like your the Y and the X, because the Z plane will be the 0, because the transfers is going on between the Y and the X plane. Okay, so other will be 0. So in the TE mode, the electric lines of the fluxes are perpendicular to the axis of the waveguide. Similarly, in this transfer magnetic field, what is going on? The magnetic lines of the fluxes are perpendicular. If we are talking about the TM, magnetic field fluxes will be perpendicular. If we are talking about the TE, the electric fluxes will be perpendicular to the waveguide. Okay. How we can write the boundary expression in the boundary conditions? Okay, because already we have studied one of the chapter or topic, that is nothing but the boundary conditions. Okay, boundary conditions in the conductor, free space, dielectric, all these things we have studied. We have seen what is the effect of your the constant parameters and the other thing, just like your the propagation, attenuation, and the gamma and all. Okay, similar to that only in the TM mode, if the Z plane is a 0 for the electric as well as the magnetic, how we can write that expression, how we can get that Z term is 0. Okay, so that is mentioned here. That is nothing but the points are nothing but your the A points here. See here the things. So A and the combination of your the electric as well as the what we can say the horizontal and the vertical plane. So here both the side X and the Y we need to focus, and we need to write the expression in the E raised to the power so and so. So what is so and so? This is nothing but your the propagation. Okay, propagation constant, that is nothing but the gamma. In which direction? That is nothing but the Z is mentioned here. If boundary condition you need to apply, so you need to think about this X and the Y which are 0, and instead of that a particular point we can write here the A and the B we are taking, and we can concentrate the X and the Y. We can plot on the graph, that is the X and the Y. If X is there in the form of your the sign, if Y is there, that is also in the form of your sign, only the values are changed, only the parameters change. Here is the X, here will be the Y cases. Now here also the one of the expression you can write in the TM modes, that is nothing but again the E at a particular coordinate system. So E at a particular is nothing but E at a Z direction, because we know very well we are having X, we are having Y, so definitely Z will be there. But at present we are interested in the Z just because the propagation is going on in the Y and the X. Okay, propagations are going on in the Y and the X. Similar to that, only the height we can find, the radiuses, radiuses we can find at the A and the B. We can find the height, we can find the propagation constant, we can find all the parameters which are related. Okay, similar to that, only in the TM mode, the many expression we are able to observe the small m, and then which is the representation of your the mode of propagation, indicates the number of variation of the fields in the X and the Y direction. Okay, in short, what we can say, what is the use of the mn? This is used the presentation of your the mode of propagation, which is indicates the number of variation in the field of X and Y direction. So in the TM mode, if n or m is 0, if n and m is 0, all the fields are 0. We remember, if if n as well as the m is 0, because there will be the representation of the count. So whenever there will be the representation, indication, and the variation of your the n and the m, and if they are 0, so definitely all the field will be treated as a 0. Okay. So see here, if you want to calculate the cutoff frequency in the magnetic field, transfer magnetic field, definitely see here the role of the propagation is equals to root of kx square plus ky square. Kx square plus ky square minus of k square. Here the m and the n are nothing but the representation of in the mode. A and the b are nothing but the radiuses. Okay. How we can find the cutoff frequency is mentioned here. How we can write the expression in the form of here the propagation constant alpha and the beta. We can find, okay, we can find the angular velocity, we can find the cutoff frequency by 1 by 2 pi root of LC, that is nothing but the resonant frequency range f0 is equals to so and so. Similarly, we can write the expression not only for the propagation constant but also the cutoff frequency. Now switch toward the other, that is nothing but you are the what we can say, or the we can write the propagation constant, the cutoff frequency. Apart from that, the other expression we can write here. See, you can observe the wave propagation. Here will be the attenuation losses, here will be propagation of a mode. Okay, that is nothing but the FC, and here FC can be calculated. Okay, the parameter can be calculated easily, that is nothing but u square by 2 into root of n by a. The m and n is important for us, whereas the m and n plays the major role. Okay, so while you are going to calculate the cutoff frequency. Similar to that, already we have done many numerical solved in the wave propagation and the transmission line. We need to study about the, what we can say, the velocity of light, the phase velocity, the angular velocity, the intrinsic impedances, the magnetic field, the electric field, and the magnetic field. Many things are there. Similar to that, only here we are trying to write the expression in the waveguides. Okay, so what is the phase velocity is defined here? UP is nothing but the phase velocity, omega divided by beta. So omega is nothing but again 2 pi f. Omega will be 2 pi f. In this way, you can find the unknown parameter, you can find the other things. Okay. Similarly, how we can find the intrinsic impedance, the particular mode. So intrinsic impedance in the TM, intrinsic impedance is the TY, intrinsic impedance while you are going to study. Here maybe the TE, here maybe the TM, here maybe the TEM. Depending upon that only you can write this expression. But this one is the fixed one, that is nothing but root of 1 minus FC by F, FC by F whole square. This will be the common. Only the change in the how we can derive, how we can write the expression of your the intrinsic. Okay. So this is the case of your the summary of your the TM modes. What is that in the summary? The wave in the dielectric medium is emission, or an inside the waveguide is emission. Beta is equals to omega divided by U dash. U dash is nothing but energy generated, but whatever the change in the energy generated is nothing but the U dash. So finally, omega root of mu 0 epsilon 0, or you can say mu 0 epsilon. In this way, you can calculate the propagation constant beta. Inside the waveguide, see here the difference between the waveguides. Inside the waveguides, B is equals to beta dash, T is equals to beta dash, angle of 1 minus 1 root of 1 minus FC by F. So in this way, you can calculate the